Hi, this lecture is about principal component analysis, and what we will do is that we will apply principal component analysis to a practical case study of an IPL season, the Indian Premier League season, and we would find the best bowler. Now, how this is applied, we will see. But before we jump into PCA, let's find out what is the definition of PCA. PCA is a statistical procedure that allows you to summarize, the keyword here is summarize, the information content in large data tables meaning a data table which has a large number of dimensions by means of a smaller set of summary indices that can be more easily visualized and analyzed. Meaning, if you have a large data set of number of dimensions, you squeeze it into a smaller set of dimensions, but you do not lose the information content so that you can analyze it very well. What we will do is that we will apply this technique to find the best bowler in the Indian Premier League, that is a cricket league in which top teams play together. Here, there are a couple of things that we would consider. One is the wickets, next is the strike rate, the balls by wickets, the average, which is the runs by wickets, the economy, which is the runs per over. Now, there are four dimensions here, and we will use, so not much of dimensions, but what we will do is that we will squeeze it to one dimension. So let's jump in of how we would do, and we would use Amazon SageMaker for this purpose. So here what we are doing is that we are going into Amazon SageMaker. We'll create a notebook instance. The notebook instance can be created very easily. I have already created one, but I'll show you of how you can create one. Create the notebook instance. You name your instance. Maybe I'll name it Ambarish 2, and you leave it the same instance type. But the most important thing what you will do is that if you want to access an S3 bucket, you need to create a new role here. You create a new role, and here you create a new IAM role in which you can access the S3 bucket. So you will create a role here. So you can create a role, and and then what you will do is that you will create a notebook instance. I have already created one, so I will not create it. So, but if you want to create following along with me, please do create it. The most important thing what I wanted to show you is that you create this new IAM role because you will need this in the subsequent place. So that's it. So I cancel it. Now, what you can do is that if you go into the PCA, you can use a Jupyter. You can open Jupyter here, and it will go into Jupyter, and now you can create a new notebook. So you create new, and here you can do conda I underscore python 3 notebook loaded. So here it's a very nice thing, and now you can carry on. So this, maybe I'll just name it PCA 2. And so another thing is that AWS, you can execute AWS commands here, S3ls. So this shows all my buckets. And this is very important because now from the notebook instance, you are able to access S3. So this is a very important part. I will not continue with this. I have my own notebook done. So we'll go into that. So you might as well delete it here. So let's open this PCA this notebook. So the first part is that we import the SageMaker. We get the session of the SageMaker. We get the bucket of the SageMaker. We have a prefix here. We get the IAM role. And then what we do is that we load the other libraries in the second cell. Then what we are doing is that we are copying from this bucket, which is the Ambarish PCA bucket. So if I go here, and if I go to this management console, And if I go to the S3 bucket, so while it comes up, it is coming up. So this is a S3 bucket, and I have the uh, file out here, the all matches details.csv. So what I am doing out here is that I am copying the file from this bucket out here to my local machine, and you will see that it's already copied all matches details.csv. The all matches details.csv is this kind of a CSV file which has the delivery number over, non-striker, bowler, runs extras, runs total, runs batsman, player out kind, and match number. So our strategy is that we can use this to do various analysis. So you can read it using pandas, using the read CSV. The runs for each bowler, what I am doing is that I am grouped by the bowlers and I am doing a runs total, and then I am summing it. So how many runs the bowlers have given. Second is the number of deliveries the bowlers have bowled. So it is a group by bowler and I am counting the deliveries. The wickets is the who has those rows in which the player was out. So those are the rows, and then we are getting who has got the wickets. So we have got all these things, and then the bowler stats. What we are doing is that we are combining all the things together. So that is the we are merging the deliveries bowler with the runs bowler and with the wickets bowler, and we are getting this data set. Next, what we are doing is that we are filtering it, and we are taking only those bowlers who have bowled more than the median number of deliveries that a bowler has bowled. So that means we are reducing our data set, and we want to consider only those bowlers who have bowled above a certain number of balls. Then we are calculating the average. The average is the runs total by the wickets, which is what we are trying to do is now what we are doing is that we are calculating this, the average, the runs by wickets. That's what we are doing it out here. And then what we are doing is that we are plotting it. So average is here and the bowler is in the y-axis, and we are drawing a plot out here, and you can see the plot. And in the middle, what we are seeing is the average. So this is what is happening. Similarly, the wickets bowler, the number of wickets that the bowler has taken, and you can see the highest number of wickets taken by Rabada, followed by Bumrah. Similarly, the strike rate, what is the strike rate? It is the deliveries by the number of wickets. So here, if you see, it is the deliveries by the number of wickets, and we are calculating it in this manner. And we are getting this also, and we are showing it in this chart out here. Similarly, we are getting the economy rate, which is the runs total by the number of deliveries. So this is what we are calculating, the runs by the number of deliveries. And if you see here, what we are doing is we are doing this, and then we are getting this value. So this is what we are getting the economy rate. And then we are sorting the deliveries, and we are getting the bowler stats in this manner. And now what we are doing is that we are uh, putting it in a data frame. All these things are the data frame. We are putting it in a data frame, and then what we are doing is scaling it, so that when we apply PCA, so when we are applying PCA, which is itself a dimension reduction technique in which we want all the columns to be in the same scale, What does a scale do is that it makes sure that the variance is unit for each of the columns. So if I do a standard deviation of each of the columns, I see it is a 1. It's practically 1. So this is what it is. One thing that I must tell you, PCA is a very interesting dimension reduction technique. I've got a full playlist on that. Please watch it. If you want to know more details from scratch, I'll place it in the comments. Now, we are not going into details about the internal workings of the PCA. We are going to use a PCA which is offered by Sagemaker. So what I am doing is that Sagemaker is interesting in the sense that we are going to retrieve the PCA container from Sagemaker, and we are doing it by the retrieve command, and we say framework is equal to PCA, and from what region we are going, we are getting it from the session, the region name, and here we are getting the container. You see, we are getting this container, and then we are converting that data frame into a numpy array. And once we are converting it into a numpy array, we are also converting it into a buffer with bytes, and then we are uploading these bytes into in this record IO format, because the container would like it into the record IO format, and we have uploaded it here, and we are uploaded it here into this bucket. Now we are using the estimator. Here we are putting it in the count, that is number 1 count, the instance type is given, the output path is given, and we are giving the session. So please note here what is it that we are given: the container, role, instance count, instance type, output path, and the session. We are also setting the hyperparameters. The hyperparameters is number of features, that is, we have got 4 features and the number of components is 3. The subtract mean is false, which means that I am not asking the algorithm to subtract the mean, which is already scaled for us. The algorithm mode is randomized and the mini batch size is 200. And then we call the fit method. It's a very interesting algorithm. Please look at the details if you want to know the details. But here we'll just see of how we are going to use it with SageMaker. So it is just doing the fit method, and it is doing everything that is given here. It is completing it, and then what we are doing is that we are deploying it into another machine, and which is an instance type of M4 extra large. We are also using the serializer, the CSV serializer, and the JSON serial deserializer. We are predicting the numpy array, and we are getting the result. So this numpy array has got projections, and it has got different things in it. So here what we are doing is that we want to get the projections, and we are getting it from the projection in the result projections, and we are getting these things that is there. So the data frame that it is found, that it is having the digits, and it has got the columns PC1, PC2, PC3, and we are getting these things. Then we are doing a reset index, and then we are sorting the values by PC1, which is a main part, and this accounts for most of the explanation of the data set. So here we see the top one is Bumrah, followed by Rabada, followed by Bolt, Chahal, Shami, Note, Archer, Rashid Khan, and Varun. So this is how, in a very short way, you can reduce the dimensions into a single dimension in the cricket analytics space. And this is a very nice way in which we combine a case study using cricket analytics and PCA and Amazon SageMaker. And ultimately, we delete the endpoint of the SageMaker. So what I'll do is that I'll push the code in GitHub as well as the data set, so that you can look at it. And if you want to know more details about PCA, there is an extensive list in my YouTube channel. Please do watch it. Thank you. Bye.